So in this video, I want to focus on what does it take to have a multi-step dimensional analysis problem. And I have two problems in front of us. The first one's already worked out. What does a one-step problem look like? Well, it means there's one conversion factor that you use. I divide by the 12 inches, multiply by 1 foot, inches cancel out. I'm left with feet, and I have the answer. Notice the units here. Inches and feet, they're both English units, non-metric units. Also, they're on basically the same scale. An inch and a foot, they're pretty close to each other in terms of size. It's those two features that actually generate examples where you have multiple steps that you have to go through. Right. Whenever you have a metric to English or English to metric conversion, you're going to have at least one conversion factor there. And then the other aspect that causes a conversion factor to be inserted into a dimensional analysis problem would be when you're dealing with like a large value going to a small value, or vice versa. Or you can also think of it as a unit that is more appropriate for measuring large things going to a unit that is more appropriate for measuring small things, or small to large. Okay. Let's look at this example here. This problem has a lot going on with it. We want to go from meters per second, which is the normal unit that you see for the speed of light, to one that we're familiar with, miles per hour. First off, let's just talk about the conversions that you see with seconds per hour, or conversions dealing with time. And what we're going to see in this particular problem, I'm going to go from seconds to minutes and then over to hours. So just in the process of converting the time portion of the calculation, I'm going to have a two-step problem. So I'm already at 2 steps in this particular problem. Now going from meters to miles, that introduces, well, actually both of these aspects. Meter is a metric unit, miles is a English unit, if you will. Also, meters, that's about 3 feet long. Miles, much larger than 3 feet. Miles is the kind of thing you use to measure distance between here and the beach. Meters, you might use this distance to measure the width of a room. So in relative speaking sense, this is more for a small object or a small distance. This is for a large distance. So you're going to have at least one conversion factor that has to factor that change in. And that's actually going to be the first step that we're going to see. So I'm going to use a unit conversion or a conversion factor that'll take us from meters to kilometers. So that gets us into the small-ish unit versus a large-ish unit. Kilometers and miles, they are analogous to each other with respect to what we use in the metric system versus what we use in the English system. And then if you look up the conversion factor charts, you can see there's one conversion factor that allows you to convert from kilometers to miles. There's that metric to English conversion here. So now this problem it's a 4-step problem here. But again, how did I approach it? I kept these things in mind, right? I want to break down each type of unit one by one and think about what it's going to take to sort of, jump my way through this kind of logical process. Do I need a metric to English conversion? Yes. Do I need something small to large? Yes. Or in this case, large. Yeah, small to large was right here. Now, another thing this is doing is dealing with what we call a derive unit, meter per second of unit for velocity. I'm not going to talk about this explicitly in this problem, but it is an example of a derived unit where you have a unit on top, or where you're starting with a unit on top and a unit on bottom, and then how do you set that up in the dimensional analysis problem. Again, you'll see it here, and I'm not going to talk about it directly. Let's go ahead and do this calculation. I'll do these two first, and then the last two will be dealing with time. I'll start with the data that's given to me. right? Each time I take a step in a path, that's going to create one of these mathematical templates that I need in my conversion factor sequence. First one, meters to kilometers. We know that there are 1,000 meters in 1 kilometer. And now kilometers to mile, if you look that up, one variation on that conversion factor is 1 kilometer equals 0.6214 miles. Why do I set it up in this particular pattern? Well, this is dimensional analysis, the unit that I want to get rid of. That's the one that's going to go on the bottom, right? Meters divided by meters cancels out. Anything on top, I'm going to multiply by. Next step, I want to get rid of kilometers, so kilometers, right? That portion of the conversion factor, 1 kilometer equals 0.6214 miles, that is going to go on the bottom so that I can cancel out kilometers, and then I'm left with miles. If I stopped at this point, and did this calculation, I would be calculating the speed of light in miles per second if I stopped here. Again, I don't want to stop here. I want to go convert the seconds to hours. Let's do that in a little bit different color just to sort of make the distinction. We know that there are 60 seconds in 1 minute. Think about how you would put that together. 60 seconds in 1 minute. Seconds originally is on the bottom, unit on the bottom. That means the 60 seconds need to go on top here, so it's going to cancel out. That means the other unit, in this case 1 minute, is going to go on the bottom. Multiply by, divide by, seconds on top, seconds on bottom, they're going to cancel out. If I did the calculation to this step, it would be miles per minute. I know there are 60 minutes in 1 hour, and I'm using the same logic that I've done all the way through here. What unit do I want to cancel out? Well, in this case, I want to cancel out minute. Minute is appearing on the bottom originally here, so that means the 60-minute portion of the new conversion factor will need to be on top, and then that places the hour on the bottom. What units are left standing in this entire expression? Miles per hour, which is what I want. The mathematics here is I'm going to plug this into my calculator, divided by 1,000, multiplied by the 0.6214 times 60 times 60. And that will give me my answer. Rounded to 3 sig figs because I'm starting with 3 sig figs in my original answer. Miles per hour. And again, what I'm doing in this video is focusing on how do we see multi-step kind of problems. For your classic, beginning dimensional analysis kind of problems, it's typically these two factors that cause, conversion factors to be inserted and steps to be created. Okay, I hope that was helpful. Thanks.